You lie in bed, eyes closed, and suddenly find yourself wandering through an unfamiliar city. The cool breeze brushes against your skin with vivid intensity, the rustle of fallen leaves beneath your feet echoes clearly, and the scent of flowers that do not exist in the waking world tantalizes your nostrils. You can even feel the subtle vibrations of the earth through your bare soles. Then the alarm clock rings, you open your eyes, and realize it was all a dream. Yet that city, those people, you have never visited or met them before. More strangely still, the familiar laws of physics are distorted. You can soar through the air like a bird, yet an invisible barrier remains impenetrable. In that dream realm, you live another life, experiencing emotions more potent than in reality, the overflowing joy of reuniting with a lost family member, or the spine-chilling terror before an unknown darkness. Today, let us explore together the secrets of the night. Consider the idea that your dreams are not mere products of imagination, but moments when you truly experience your life in another universe. Do not dismiss this as fanciful fiction or a distant tale. Take it slowly, with a steaming cup of coffee before you, imagining the patter of rain against the windowpane creating a cozy atmosphere, and sense the approachable warmth of this concept. Let us journey back to 1957, to Princeton University, where a young physicist named Hugh Everett proposed an idea that sounded utterly mad at the time. He argued that when a quantum event, a tiny decision at the level of fundamental particles, occurs, the universe does not select just one outcome, but branches into multiple parallel versions. In one universe, at a crossroads in life, you turn left, in another, you turn right. These worlds exist simultaneously but cannot intersect, flowing like parallel rivers that never merge. This theory, known as the many worlds interpretation, initially faced much ridicule, yet it has gradually become a significant part of modern quantum physics. According to this interpretation, since the Big Bang gave birth to the universe approximately 13.8 billion years ago, countless branchings have occurred, generating billions of parallel universes. Every choice you have made, every opportunity missed, such as abandoning a passion for music or failing to confess love to someone dear, is unfolding peacefully elsewhere. In those places, another version of you might be living happily with a different family, working in a distant city, or facing challenges unimaginable here. Recent research in 2025, including experiments with Google's quantum chip named Willow, has provided results that support the existence of many worlds, suggesting this theory is no longer mere speculation but backed by experimental evidence. The Willow chip, unveiled in late 2024 and further analyzed in 2025, demonstrated error-corrected quantum computations that align with the branching predictions of the many worlds framework, sparking debates among physicists about its implications for multiverse reality. Now, envision a warm room where a soft golden lamp illuminates ancient scientific tomes. If countless versions of you exist, might there be a connection between them? Some scientists, such as the renowned Michio Kaku, believe the answer could lie within our sleep. When we drift off, the brain does not shut down like a computer, instead, it shifts to a special state, akin to tuning a familiar radio station to an unfamiliar frequency. Activity in the frontal cortex, the region responsible for logical thinking and self-awareness, sharply decreases, shedding the rigid shell of reality. In contrast, the brainstem and limbic system, managing deep emotions and primal instincts, surge with explosive energy. You become freer, with emotions rising like a turbulent river. Joy and sorrow intermingle, fear and excitement blend. Even more intriguing is the brain's massive release of the neurotransmitter acetylcholine during sleep. This substance not only induces rapid eye movement sleep, the phase where the most vivid dreams emerge, but also synchronizes brain waves highly, transforming the mind into a precise receiver capable of capturing distant signals. Some scientists hypothesize that this state opens a doorway for consciousness to receive signals from another self in a parallel universe. It may sound peculiar, but recall your own familiar dream experiences, encountering a stranger whose every wrinkle is sharp, whose voice feels warm or cold, whose expressions are lifelike. Upon waking, you are certain you have never met them in reality. Traditional dream theories explain this as the brain reorganizing information from the day, but how can it fabricate a complete person, with a unique personality, lengthy conversations, and intense emotions? It strains credulity to attribute it to someone glimpsed fleetingly on the street, especially when they interact deeply, making your heart pound or tears flow. In 2025 research from Harvard and Stanford, scientists proposed that consciousness originates in the brain's microscopic quantum structures called microtubules, which could connect to parallel realities through quantum entanglement. The increase in acetylcholine during rapid eye movement sleep is said to strengthen these connections, with further studies in 2025 emphasizing how anesthetics target microtubules, providing experimental support for quantum processes in awareness. Imagine strolling down an antique street in a dream, where the light tinkling of bells resonates clearly. Suddenly, the place feels eerily familiar. You know there is a small cafe around the corner, and that path leads to a verdant park, despite never having visited in waking life. Upon awakening, you search the internet and are astonished to find it exists, a quaint village in Europe or a rural area in Vietnam. Traditional science might call it coincidence, but under the many worlds theory, it makes sense. You have been there, just not in this universe. Moreover, in lucid dreams, where you realize you are dreaming and attempt control, you might glide freely among white clouds, feeling the chill wind on your face, yet fail to pass through a solid stone wall or alter others' thoughts. If dreams were mere brain illusions, why could you not manipulate everything at will? Perhaps because that world possesses its own independent rules, existing in another dimensional space. In the latest 2025 research, Roger Penrose and Stuart Hameroff's orchestrated objective reduction theory, often abbreviated as ORCHOR, posits that consciousness emerges from quantum processes, with experimental evidence pointing to microtubules as targets for anesthetics, implying quantum entanglement could link to multiple universes. On platforms like X, formerly known as Twitter, reliable scientific discussions among physicists suggest dreams might be leaks from the many worlds interpretation. One prominent account in 2025 emphasized, dreams are not random, they could be vivid evidence for Everett's many worlds interpretation. Additional hypotheses propose that dreams involve experiencing multiple realities simultaneously in a quantum superposition state, supported by Google's 2025 quantum experiments. These advancements in quantum computing are also being applied to consciousness studies, exploring hybrid quantum classical architectures that could mimic or enhance human awareness. How profound are the implications of this concept? Consider great inventions born from dreams. The chemist Friedrich August Kekulé dreamt of a snake biting its tail and awoke to realize the ring structure of benzene, forming the foundation of modern organic chemistry. Dmitri Mendeleev saw elements arranged like cards in a dream and created the periodic table. Elias Howe, the father of the sewing machine, dreamt of savages holding spears with holes at the tips, inspiring him to place the hole at the needle's end. This is no coincidence, perhaps they are borrowed solutions already resolved in parallel universes. Moreover, Descartes' new science, atomic structure, Srinivasa Ramanujan's divine revelations, Einstein's theory of relativity, and Larry Page's idea for Google all drew inspiration from dreams. The sense of loss upon waking, as if months or a lifetime passed in the dream, stems from time distortion, where hours of sleep feel like years, possibly due to differing time speeds between universes. The brain could not create such vast information instantaneously, so it must come from outside. In 2025 studies, quantum computing is applied to consciousness research, suggesting these dream connections could lead to inventions in new dimensions, with explorations into entangling human brains with quantum systems to expand awareness. And then there is déjà vu, that strange familiarity with something entirely new. Entering a new restaurant, you feel as if you have sat at that table, hearing laughter echo. In conversation, you predict the next words precisely. Traditional theories attribute it to brain storage errors, yet the details are too accurate. Michio Kaku proposes déjà vu as a leak from many worlds, something another you has already experienced. 2025 research from Cornell University, echoed in scientific news sources like VietnamNet, mentions how universe expansion affects quantum connections, potentially making déjà vu more frequent. Some theories view it as quantum entanglement causing time loops or intersections of parallel realities. Now you may question your own dreams, the faint images, the hazy emotions upon waking, the strangers who feel known. They are not mere brain housekeeping, but signals from another you. Of course, this remains scientific speculation. The many worlds have not been experimentally proven, though mathematically sound. Before full understanding, view dreams from a different angle. Next time you awaken from a strange dream, smile and wonder, have I just returned from a real adventure? I shall reveal to you a secret that alters how you see yourself. If we analyze our bodies down to the most basic particles, what do we find? The ashes of dead stars. Yes, each of us is a descendant of stars, formed from stellar dust that wandered the cosmos for billions of years. Tracing this lineage, from the nearest star to the universe's edge, let us unravel the greatest mysteries of the cosmos. We begin with the Sun. That familiar star illuminating daily life has burned steadily for 4.6 billion years due to an unceasing tug-of-war, gravity pulling everything inward, while the energy from nuclear fusion reactions pushes outward. This perfect balance determines the size and fate of every star, making the twinkling points in the night sky feel like notes in a vast cosmic symphony. Imagine lying on lush green grass, the night breeze carrying the scent of Earth, gazing up at a star-filled sky. Let us examine the humblest stars first, red dwarfs, the most common in the universe. 2/3 of the Milky Way stars are red dwarfs, including Proxima Centauri, the closest to the Sun at 4.2 light-years. The smallest known red dwarf is EBLM J0555-57 AB, 600 light-years away, with a mass 85 times that of Jupiter and a radius close to Saturn's. Any smaller, and it becomes a brown dwarf, an object between planet and star, where the core faintly burns before cooling, like a dying ember in an endless night. These stars burn slowly for billions of years, offering stability amid the chaotic cosmos. According to 2025 updates, astronomers have discovered new giant stars like RSGC-1 Ref01, refreshing previous records and confirming it as one of the largest known. Now, look to the grandest, supermassive stars. The largest and most powerful, R136A1, resides in the Large Magellanic Cloud, 160,000 light-years away. It has a mass between 170 and 230 times the Sun's, revising older estimates of 265, and shines millions of times brighter. Its high temperature emits mostly ultraviolet radiation, invisible to the eye, but if placed at Proxima Centauri's distance, it would outshine the full moon, turning night into day. Such immense mass creates intense gravitational pressure at the core, accelerating nuclear fusion and leading to a supernova explosion after mere millions of years, a spectacular death that scatters stellar dust to birth new generations of stars. In the early universe, without interference from heavy elements, stars thousands or even 10,000 times the Sun's mass were possible, acting like colossal cosmic bombs. 2025 research has re-evaluated stars like WOHG64 and Stephenson 2-18, positioning RSGC-1 F01 as the new record holder, with estimates of its radius reaching up to 1,530 solar radii. Are there celestial bodies larger than stars? Yes, molecular clouds and black holes. Stars form from vast molecular clouds, gas and dust drifting through galaxies. Disturbances like supernova shockwaves compress them into dense clumps, igniting nuclear fusion. The largest is Sagittarius B2, with a diameter of 150 light-years and a mass 3 million times the Sun's, near the galactic center. That region hosts Sagittarius A, a black hole with a mass 4.3 million times the Sun's, governing the orbits of billions of stars. The Milky Way star count is known through the European Space Agency's Gaia telescope. By 2025, Gaia has observed over 2 billion stars in detail, yet this represents only 1% of the total. Estimates range from 100 billion to 400 billion stars, across a galaxy 100,000 light-years in diameter and with a mass over 1 trillion solar masses. 2025 Gaia data provides three-dimensional maps of 44 million stars, detailing star-forming regions and revealing chains of starry gatherings, proving our skies are filled with such structures. The Milky Way is average compared to other galaxies. Our neighbor, Andromeda, is twice as large, with a diameter of 220,000 light-years, about 1 trillion stars, and 2.5 million light-years from Earth, a journey that would take Voyager 1, traveling at 17 kilometers per second, 44 billion years. Further out lie galaxy clusters, such as Abell 383, with a diameter of 1.8 million light-years, equivalent to 10 Andromedas, densely packed like a cosmic city. Superclusters, like Laniakea, to which the Milky Way belongs, span over 500 million light-years, encompassing hundreds of galaxy clusters. The Virgo cluster is but a small part. The largest known is the Hercules Corona Borealis Great Wall, stretching 10 billion light-years, nearly 1/10 of the observable universe. In 2025 research, the largest rotating structure was discovered, 14 hydrogen-rich galaxies aligned over 5.5 million light-years. The observable universe is a sphere 93 billion light-years in diameter, but the actual universe is larger, as distant light has yet to reach us. The universe expands, with far-off galaxies receding faster than light speed, not through motion, but because space itself stretches. The light we see is billions of years old. In the future, many galaxies may vanish from view. Once thought infinite, the universe puzzled thinkers with Olber's paradox. If infinite, the night sky should be bright, but the Big Bang resolved it. The universe is 13.8 billion years old, and light is finite. The universe's fate depends on gravity, but dark energy, comprising 68% of the cosmos, a mysterious force, accelerates expansion. However, 2025 data from the Dark Energy Spectroscopic Instrument, or DESI, indicates dark energy is dynamic and evolves over time, possibly negative, challenging existing models and suggesting the expansion rate peaked 2 billion years ago and may slow, potentially leading to a big crunch. We sit at the balance point of the four fundamental forces: the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. At quantum scales, gravity is weak; at cosmic scales, the others fall silent, and gravity reigns. Each of us is a star, observing the cosmos, viewing the past through starlight. We maintain balance until we return to stellar dust. From dreams to the vast universe, everything connects, granting us a small yet one